I'm ready.
Good. Okay. Well, welcome to our webinar. My name is Ken Gracie. I think I know most of you or half of you, and I welcome you to the webinar. I could see you're spread out all over the world to some extent, so thanks for staying up late. If this is something totally new to you and you're wondering if you're in the right place, well, you probably are, so don't worry about that. What we're talking about today are some new additions Parallax has made to our BlocklyProp programming environment for our microcontroller, the Propeller multicore. So we've combined a cartoon-looking visual programming language with a very capable physical hardware. So this is quite exciting. I think we've extended the use of Blockly far beyond what it was originally intended to do, but the results have been good. So today I'll be showing you some of the updates to Blockly that we've made, and you should be able to see my slideshow now. So how do you interact during the webinar? There are a couple ways here. You could do the Q&A, which you'll see a Q&A button on your control bar. You could press that and then type in a question, and then we'll answer it. There's also a chat function. So we'll monitor that from a secondary standpoint, but feel free to leave questions there too. And if you want to talk, raise your hand and talk. Then we unmute you. Stephanie will unmute you, or Kate will, and then you could say whatever you want to say. So I encourage you to participate any way you want to. We've all participated in really boring webinars where we hide behind a PowerPoint slide deck, but we really try to mix it up. We do things that might break the system here between connecting hardware to the computer and switching browser windows and whatever. So be prepared for that. There will be hiccups. Oh, one more thing. On the video display, you'll see a little button, two buttons in the upper right-hand corner, which can switch you between the gallery view and speaker view. So there will be times when I'm showing something up here on the video, and I want you to get a close look at it, and then you can switch to the speaker view to see whatever I'm showing you. All right, good so far?
Perfect.
Thank you. Okay, then. This is our agenda, and it's kind of packed, but we're going to move through it quickly. So first, welcome and introductions. On my team from Parallax today, I have Kate Hay, who's our STEM Solutions and Sales Manager, and Stephanie Lindsay.
Hello.
And thanks, Steph. And it looks like Whit is joining us too as a panelist, and Eric, and well, whoever else wants to. I welcome you in. So what we're talking about, I've divided this up into three main pieces. The first one will be our BlocklyProp Housekeeping, which is tips for new users, and then how to manage big code in Blockly. And I'll show you a few tips there. Next, we'll do some block improvements. I'd like to show you how we've enhanced a few blocks that you're using all the time, just to make your life a little bit easier. And all of this came from user feedback or internal feedback where we said, just if we could do this, this would be so much easier. So I could easily conduct a whole webinar on any of those individual blocks. And then finally, I'll show you some new hardware that we're supporting in Blockly. It's listed right there if you want to look at it. Some of it has extensive support behind it with libraries and code development from others. So it's pretty fun. Questions and answer. Ask questions anytime you want, typing them or whatever. Hello, Jacob. And yeah, we'll answer them, or just like I said, raise your hand and talk, because it's really hard running a webinar when it's very quiet. I almost could have pre-recorded it if I did that. For the total newbies here, you might be confused about what all this is, you know? So we're using a visual programming language called Blockly from Google, and Parallax has ported this to the Propeller multicore. Okay, so this is a very popular language right now in education. And what we're talking about today is our adaptation of Blockly targeted for our hardware. Okay, so Blockly is a visual programming language I consider a super language, because when you read Blockly code, you see similarities that occur in all kinds of languages, like looping, variables, logic, functions, etc. And we're doing this with physical computing. So we're talking about Blockly with microcontrollers, like this one, which is the flip. And then probably this too, the propeller activity board. So we're writing code that goes into these devices. Here is an article that I just finished writing that's a very kind of introductory explanation of Blockly as we're using it. And at the end of the webinar, Kate will forward it to you. So all of you will get a link to this article in your email, which will give you some of the background that you might be missing from me talking. What we're about at Parallax? Well, all kinds of things. Foremost, STEM education. We serve largely educational customers. We've been doing this for 20 years. We make the most popular programmable robots and curriculum. Our goal is to really get students turned on. We make the kinds of tools that we would have loved to have had as students. We also teach teachers in professional development courses. Right now, we're in the biggest effort we've ever initiated. We have 500 teachers enrolled in classes around the country. And in fact, some of our staff right now is out at those courses. The course for about electronics and circuits, that's how we're using our tutorials and Blockly. And we are a California company. We manufacture and work in California. Our team, just so you could put some faces on this, chances are, if you've interfaced with us, you've talked to a handful of these people. Every single person in this picture has an important role at Parallax and in what you're seeing today. This is what it takes to make BlocklyProp go. Most likely you run into people like Andy, Stephanie, Miguel, Courtney, Jeff, David, Matt, Jen, or Kate, or myself. So these people put in numerous hours to everything we do at Parallax and to training our teachers and working with students, etc. So for the housekeeping side of this, tips and tricks with BlocklyProp. This message is primarily for existing users on Windows and Mac machines. We've upgraded our BlocklyProp client recently, and on Windows and Mac machines, it does not automatically install or download. When you go to the login screen, you'll see the link on the bottom where it says BlocklyProp Client. Click on that, and then it will pop up for your operating system. Chromebook users get this automatically. And this upgrade is much faster, more reliable, fixes some problems we were having, particularly with the Chromebooks. Email. This message is primarily for teachers. BlocklyProp is TAPA compliant. If you're not familiar with TAPA, it's a federal regulation that protects students age 13 and under by requiring parent or teacher consent and privacy, among other things. So up until now, students who are 13 and under, well, this is still the case for them, are required to submit an additional email address for their teacher to validate the account creation. However, if you entered a birth date that made you over 13, you did not receive this alternate email box. And this was a problem because in most middle schools in the country and in high schools, the student email accounts are blocked from receiving external email, like from parallax.com. So for everybody now, you can enter an alternate email address. And I just encourage you to have your students do this. Sometimes they mistype, and well, we've seen it all happen. So every once in a while, we have to go into our server and fix things for you, and that's totally okay if you get locked out. Just send us an email to learn@parallax.com, and we'll just get right on it. Also, as we talk about some of the new blocks here, Stephanie has done an excellent job maintaining the BlocklyProp reference. And you can right-click on any block that you see, and it will take you right to the help file for that block. So between the reference and our tutorials, you have a very complete learning system. You can learn just from reading the reference. So I won't be doing this actively in the webinar, but just know that it's there. So as we have a capable processor, people are making bigger and bigger code with Blockly. And I think in the beginning, Blockly code was always, half an hour effort, could fit it in the screen, but now things are very different. So I want to show you 7 quick things that you could do to make managing your project just a little bit easier. So I'll jump into a project here. This particular project is the ActivityBot 360 color line follower, and as you can see, it's actually too big to fit on the screen, which brings me to the zoom in and zoom out. You could do this a couple ways. One way is Command plus and minus, all right, which I'm doing right now. Or you'll see down on the right side, Matt has added plus and minus. So you can do that too. Right above it is a new button that centers your code, okay? So it looks at all your code, finds the outer limits, and then plops it in the middle of your screen. This is great because I've had big programs where things really get away from me. And I know that some customers, like Carol, who just joined us, work with GPS and their programs just get massive. Also, when you're in here, you can right-click, and you have to be at 100%, okay, to make all these things work smoothly. If you right-click on a function, by the way, this is my main program right here on the left, okay? And if you notice, the way I build programs is I try to put as many things as I can in functions, and then it lets me really compartmentalize the code. Anyway, you can collapse blocks by clicking on the outer one and then choosing collapse. So this will tighten up all your functions. And then you can move them around wherever you want. If they're working well, you don't have to look at them. I encourage you to do that. Also, inputs. Inputs can be set as external or inline. So let's look at a block that might show us that quite well. How about this one? We'll send this over to external, okay? Then it narrows it up versus inline inputs. In regards to the help, I mentioned you can get to it just by right-clicking and then going to help. So this is the frequency block, and here you have the help file for the audio category and the frequency block. Really nice to have. Back in here, I'm going to recenter the code, and I'm going to zoom out so you can just see how it's a little bit smaller. And I'll collapse these functions. And then there's one other, whoops. Okay, and then there's one other thing, which is clean up blocks. Boom. So what does that do? That puts them all in a nice line for you, right? So that's also handy. And finally, the code view. Okay, if you click on this button, then you can see your C code. And at the moment, you can take this C code out, plop it into simple IDE, and then change it and program from there. However, in the future, and I know this excites a lot of the teachers, you will be able to edit and download from here, but it will not be reverse compatible back to Blockly. So you cannot change your C code and then expect blocks to, regenerate themselves. Okay, moving into section 2 here. So we'll be talking about improvements that have been made to blocks that already exist. Here's one. This is the IO pin definition feature. And to demonstrate this, let's just hop into a code again. All right, so this particular code, what it does is it monitors the ping, gets a measurement, and then it takes that measurement and then it remaps it to a higher value so you can actually hear it. We can just demo this for a minute. It's always fun to show hardware. Whoops, need a power supply. Got to turn on the speaker. Okay, don't want to disturb my office mates, but you get the idea how it works. All right, so how do you populate a block with an IO pin? Let's look at the frequency block. And there's several that have this. All right, so what this gives you is better syntax troubleshooting in your code. So if you drag out a block, and you'll see this for, let's see, frequency, pulses, servos, most of the commonly used blocks. And then you choose pin, you could choose other. All right, once you've done that, then you can drop a constant in there, a number, and have it defined throughout your program. Okay, so all I have to do if I ever change IO pin is change it here, then all the blocks that use it will also change. But of course, you'll want to put the variable in there, just like this. Okay, I think it's a nice addition. And by the way, that does use a variable. So it consumes a little bit of RAM, but in the future, we will create constants for that job. Okay, now this one's a biggie. It's a little bit of an illusion too, because you think floating point, Blockly can do floating point. Not yet. Blockly is an integer-only tool. However, now you can display in text, decimal, hex, binary, and floating point any value that you have. So we've added blocks that work with the terminal, which is the black terminal that pops up, with an OLED display, which are these, and then with a serial LCD. And it's called the print multiple block. Let's go take a look at one of them. Okay, so how do you do this? This happens to be, oh, it's an A to D converter. Let's just turn it on so we could look at it. So it's a potentiometer connected to an A to D converter on the propeller activity board with an OLED. So as you turn the potentiometer, you'll see different decimal voltages displayed and the decimal value. Okay, so looking at the code here, the way it works is quite simple. You just get one of these blocks, and I was showing you on the OLED, but it's the same for terminal. In fact, we'll download this code and get a look at it. Right here, drag that out, and then you click on the gear icon, and then you can drop anything in here you want. So, you know, if you want to use floating point, just drag that in. You can specify the number of digits, and then the block changes, and then you can plug into it like a text label, the number of digits you want to display, if you want to divide it, or whatever, and then it will print you a decimal value. So why don't we just download this code, then we can also see it working with terminal. Because I think that's most likely where you would use it. People think I'm a little bit crazy with the OLEDs because I'm always using them. But, you know, they're just my favorite way to display things. Okay, so now you're going to see terminal display of these values. And then also you could see it on the OLED. You might even see a bug in my code if you look carefully. The bug is actually on the hex display. We found that last night, so that'll be fixed pretty quickly. Any questions so far on that? Okay, useful, right?
Great.
Okay, good. And by the way, if you're thinking about doing floating point math in Blockly, you can learn about integer math, which is if you have a value, you can multiply it up by 10 or 100, do that with all the other values, and then just decrease it when you finally display it. And there is an operator called modulus, and there's a block for it, which can allow you to display the right side of the decimal point. So here's another look at what I was just showing you. Okay, the next thing is PEMDAS. I hadn't heard this acronym, believe it or not. I knew what it was, so I had to ask my son. He said, well, duh, we learned this in 5th grade. This is order of operation. Please excuse my dear Aunt Sally, something like that. So Matt has created a super block in Blockly, which you can populate a complex expression, and the order of evaluation will be taken care of for you. And it looks like this. We'll just make a new blank project really quick. So it's under numbers, or wait a minute, values, where is it? Variables.
What are you after?
I'm looking for the multiple math operation block.
Back to operators numbers. It's hard to see because it looks like it did before right at the top. It
it's
just
right
has
here.
the
Yes.
gear on it.
That's it. Thank you. That was almost queued up. So what Stephanie pointed out is very important. There's a gear, and that allows you to change it. So I was expecting a big long block, but it was the same looking one. And you could just plop all the terms you want in here. And then, yeah, put your equation in, attach it to a variable. How about a variable named item? And away you go.
Can you show transforming that block
Oh,
to
back to
external
the,
input?
sure. We'll just close out of there.
There you go.
So transforming it to what?
Right-click on item.
Okay.
I think you'll need to close the gear first. So click the gear to close it. Now right-click on item, down a little farther. You don't want to rename it. You just want to change it to external inputs.
Oh, to external inputs. I think right
Yeah.
here.
There you go.
There. Okay.
And that's what you've done to have it look like that in the next slide.
Thanks. PEMDAS. You know, this one's a biggie for me. And it's a problem we've often faced. Anyone who does any kind of like robotic work or sensors, where you have one value as an input and then you want to turn that number into something else, this block simplifies your life tremendously. And it's called the map value block. So how does it work? Actually, we will use a demo to demonstrate it. So this is the toaster bot. Kind of tilt the screen down here. There's nothing that shoots fire in this particular webinar. Bummer. I know, yes. So we'll turn this on. And then we'll talk about the usefulness of the block after we have it running. Okay, so I have a handheld remote controller, and there's an accelerometer on it, and there's an XB on it as well. Okay, so I'm sending data to the toaster. And when I tilt this, go forward, robot goes forward or back, or turns. Have to be careful it doesn't go off the table here. Okay, so the challenge with a project like this is that the accelerometer output values are -90 to +90, but the motor control values are 0 to 128. All right, so this is where the map block comes in really handy. Now you can do the math on this, but I assure you after you do it a few times, you'll introduce some errors and you'll wish you never had to do it in the first place because it's very difficult to read your own code. So here's an example using the new map block and then using math the old way. So suppose you have a number that ranges between -10 and 123, and you'd like to remap it between 500 and 700, right? One way, shown on top, is with the map block. Just put the number in and then tell it where it lives currently and then where you'd like it to live. And then the second way is using math, okay? So in the second way, you find where it fits in its range as a ratio, and then you apply it to the new range, and then you add an offset. So the two yield the same result. But the map block makes it very easy. And it seems like every robotic project I do, I run into this. And just, I'm thrilled to have this block. In fact, here's another example where we're using it. And I'll plug this hardware in so you can see it because it's worth looking at. This is a robotic boat platform. Turn off the video on it. Or I'm sorry, the audio, if I could figure that out. Anyway, it's covered up by the control bar, so that's not going to happen. So this boat has 2 thrusters on it with electronic speed controls. And before I deploy anything out into the wild, especially autonomous, you like to test it under remote control, especially if it's a big robot like this. So this particular robot is behind me on the table, and it weighs about 40 pounds, and it's 3.5 feet by 3 feet. So it's a formidable vessel. And the programming challenge here consists of sending it signals with one of these, and then receiving them, mixing them, and then controlling the thrusters. Okay, so that we could actually just drive this boat around and then test its seaworthiness. Oh, and of course my battery on that is toasted, so I'm not going to be able to demonstrate that to you, which is too bad. But this is done entirely in Blockly, and it's using map. So you can see here the map block. The goal of this project is to show real-world Blockly projects. I intend to put this boat in Lake Tahoe and have it navigate the 29-mile lake totally on its own. And it should be programmed all in Blockly. So this will be a project for the spring here, after our webinars are all done. Yeah. Lake Tahoe is a lake where we study the environment, we study the temperature, the chemical concentrations, turbidity. If there's any parameter to measure in Tahoe, it wants to be measured by a robot.
And I think Carol's got some input here.
Carol.
Yeah, if you go into the BlocklyProp libraries online, you'll see where my autonomous truck project shows how to run an RC radio with BlocklyProp.
Excellent. And you're probably doing the math the hard way there?
Now I'm using the multiplier
Yep.
method.
Excellent.
What it shows though is on a lot of RC radios, if you want to reverse direction in that, you have to send it a couple different codes. And that's in there so that you can use the RC radio exactly like an RC radio with the ESC that comes with radio control equipment.
Yep. Yeah, some of this programming could be done on the radios or it could be done in the microcontrollers. So on this boat, there's a propeller activity board which sits between the receiver and the ESCs.
Yeah, I made mine so that I could switch it using the radio and the gear, what they call the gear switch up on the radio. I can switch the radio back and forth between RC or autonomous.
Yeah, that's an excellent programming tip. So if you put something out there into the wild, you need to be able to take control over it at any time. So what Carol was doing was not just monitoring the receiver channels, like the aileron, the throttle, but she was also monitoring a gear switch so she could take over control of it again. Excellent point. Moving on, some hardware to show you that has new blocks. The first one is a CM2302 humidity and temperature sensor. This is a low-cost sensor. I think they're about $8. We have them in our store. When we work with sensors like this, we have to make decisions about how we handle them in Blockly. Like, will we try to code it with Blockly blocks that exist, like the analog blocks, the serial blocks, the pulse blocks, or is the communication protocol just complicated enough that the sensor is best served by having a custom block? In this one, it had a one-wire serial type protocol. Matt wrote a library for it, and then at the end he said, okay, here's a block. Just talk to it with the block. So we had to make the choice just to make a block, which we like to do because it's a lot easier to get these things working. And quite truthfully, in most classrooms, you don't have a lot of time except to do this. And this lets the student focus on the project instead of actually just making something work. So they can make the subsystems work quickly, and then they can focus their code development on the physical aspects of the project or the logic of it. So here's an example of that sensor, just mounted on a propeller activity board with an OLED display. So it's quite responsive. If you blow on it, now it's very humid.
Like Louisiana.
Yes. And I've been to Louisiana in July, and I don't know if I can go back. It is an unusual kind of weather. You have to be acclimatized for it. Okay, so next is the Feedback 360 Servo. So this is a servo, if you can call it that. It's really a closed loop feedback motor that Parallax spent a year developing with a servo supplier in Asia. And you'll notice that it has a yellow line which comes out of it, okay? So that yellow line, that IO, is actually a feedback that we can use, we can monitor in our code so that when we give the servo a position, we can actually check its internal Hall effect sensor and see where it is. So to support this servo, we have blocks now where you can use the servo on its own, because this is both a continuous rotation servo, So you could tell it to go to 1400 degrees, or it's an angular position motor. It does both, all right? And this is really, really crazy, but to make good use of it, Andy spent a good part of a year writing a library that is in Blockly that we have access to now, where we could simply tell the servo to go to an angle, or we can read its position back. And this servo is what made the ActivityBot 360 possible. And to give you an idea, the importance of encoders in robots, there are fewer educational robots that have encoders than you'd imagine, but they're absolutely necessary for anything where you're doing distance equals rate times time, okay? So you have to have a distance component to have a useful robot servo, and that's for something called dead reckoning, where you want to just travel a certain distance before you do something in particular. But to give you an idea how well this works, I'll just put it here on my table and have it turn around and just go back and forth. And you'll see that it maintains its position quite nicely, making some little adjustments at the end of each turn. This is going about half speed. So another use of this servo, and by the way, you're seeing the code that it's running on the left side of this slide. So we'll turn that little guy off. Let's look at something else I made last night that uses the servo in a different capacity. So this would be a turret, all right, that's 2 degrees of freedom. So you have panning, and then you have tilting. And on it is a laser peen, all right? So this was done entirely using the servo Feedback 360 servo blocks. So let's just turn this on and see what it does. Okay, I'll move it back a little bit. So as you can see, it's just rotating through, I think, 10-degree increments, and then checking 0 to 90 degrees, the distance with the laser, and then writing it to the display. So this could be used, I'm sure Carol has a lot of ideas, but maybe finding the most open area in a space so you can navigate freely with the robot.
I got something a lot better than that up my sleeve here, Cal. I'll keep you posted.
Oh, do share. Do you want to tell us now, or do we have to wait and see it on the interwebs?
Well, I'm putting a like a red laser, there's a visible one on my laser ping right now, but I want to sort of reproduce. I don't know if you saw, but I made a BS2 laser scanner before. It was to go in a Servo magazine article, but with this previous laser scanner, I could sort of detect black and white, lines. So
Okay.
actually, I wrote the word servo on, in black letters on a white piece of paper, and I scanned that. And so I displayed that so you could actually see the letters SERVO displayed on the debug screen, sort of like what you guys do with your ping dart display, which I think is one of the best, uses ever. But anyway, what I'm doing, about halfway done now. Had it started before 23rd. I've got to get back to it, but anyway, I want to cut out letters in various shapes, or maybe start with a P for Parallax logo, and then just do a real slow laser ping scan with that, and then that is so like this big 3D letter P is so far in front of the foreground that it's detectable just point by point. Either you see something in the foreground or the background, so you'd also see that displayed on the screen.
Be sure to share that on the Blockly for Microcontrollers Facebook group too.
Yes, I will.
I'd like to see that. If it has to do with lasers or fire, it's always in your house.
Yes, it is.
Okay, moving on. Here's another example that would benefit from this servo. This is a project I just found on our forums a few days ago. And this is from Nikos, who's a Greek teacher and mathematician. So he's obviously setting angles here and using regular servos. This is a rubber band laser gun shooter. So you can see that on our forums, and it's mounted on a scribbler. And here's a short video of the turret I was just demonstrating to you in case it was hard to see on the camera view. So of course, after I wrote this code, I promptly lost it. when my computer shut down. But you can imagine how it works. Yep, that happens. So the laser ping, this is a new product, and what's nice about it is it has the same interface as a ping ultrasonic sensor. So you can use the ping block in Blockly to talk to it. And here's a little video that just shows where one was swapped out for the other. I'll jump right to that point for you. Actually, it's right about here. So yeah, pull the ping out, drop in the laser. Yeah, same thing. So the benefits of the laser ping are that you can read it much more quickly. And it works better with a variety of surfaces where the ultrasonic sensor might have trouble if it shoots at an angle and then it bounces the other direction instead of back to the sensor. The laser ping will also work with things like fabric, where an ultrasonic sensor might absorb the sound waves. So
Its size is very compact too.
it's pretty small.
Hey, Ken, I haven't looked, but I mean, are you able to like view the dot of the laser using like your cell phone camera or anything like that? Like infrared?
I haven't checked that, but we can, of course, check right now.
You can.
You can? Okay, so you see it, right?
Yep.
There it is.
Yeah, so there it is.
It's a near infrared laser, and it actually has more of a projection cone than a even diameter cylinder dot. When you're using it, take a look at the documentation to see how that works.
Okay, very good.
Thanks.
Thanks, Steph.
I'll add my figure 8.
Okay, tell us what we're looking at, Carol. I harvested this picture from you. What are you doing?
I am copying one of Eric's old projects. He did a spider that do a figure 8 instead of just being programmed to do the figure 8. It actually looked at an object and walked around it, got between two objects, and walked around the other one.
Can you say Bose bottles on TV?
Okay,
Well,
so this is
I'm
the
not
figure 8 challenge with
Yeah.
two bottles, and
Right.
the robot has to navigate around them drawing an 8, and you're using the laser ping to keep its distance from the bottle on the right side, and then when it sees a bottle on both sides, it stops in the middle, right?
No, when it sees a
Different.
bottle on both sides, it switches to the other way, so it goes around both bottles over and over and over again. Then you can pick a time for it to stop. I was thinking of doing like 3 loops. Then on the third time it sees both bottles, it would stop. The hardest thing about it, the programming in BlocklyProp for its piece of cake, was figuring out a way to mount the pings that they look sideways out from the Phobot. And that's the picture I sent you.
I got it. Okay, so
I would like to use that same kind of setup. I was thinking about actually setting it up on the S3 or an activity bot and have one of the pings facing forward and one either to the right or the left, and use it for maze solving so that I could keep a right hand or a left hand on one wall, and on a simple maze you could solve the maze like that.
Good call.
now for the other attendees here, I should let you know these people talking about this challenge, they're nearly crazy. There's a 50-60 page thread on our forums about this exact challenge called Urko's Figure 8 Challenge, and they just won't give it up. So the laser ping must add a new dimension to their excitement. I've not jumped in. I don't have a horse in that race yet, but I watch it from time to time, and it's entertaining.
What?
I want a figure 8 on the boat on Lake Tahoe.
Yeah. I think I have about 6 different robots in the challenge. Urko's got the most, though.
Okay, moving on to something totally different. We all love robots, but lights. So if you have seen this picture before, you'll know it's from an Anheuser-Busch commercial during the Super Bowl. 2 years ago, and this is a full life-size Pac-Man game, and each of these Pac-Man, Inky, Blinky, Clyde, I forget their names, it's been like 30 years. These are actually roller skaters, and they're wearing a whole bunch of LED strips that look like this. Okay, these are WS28 LEDs. Each of these LEDs has 16 million colors. Carol's showing them as well. And you can set the color and the intensity in BlocklyProp. Okay, so this was actually a propeller multi-core project. So for the teachers, if you want to show your students something real, you can grab this video and show it to them. The same thing that they do with their little robots, like this robot that I'm about to show you. This is actually a ColorPal sensor, and I've set with regular line following QTI line follower sensors, and I've created just a little test board for a future project where I could do color line following. So the way this LED is used is it simply takes the output value from the color of tape, like here it's on blue, and it's hard to tell, but that's a blue LED or red. Maybe that's a little better, it's on red tape now. So these LEDs are available individually. We have them as singles. You can control them individually or in these big strips. So these Pac-Man skaters are wearing huge lithium polymer batteries like this. Okay, you wouldn't want to get sweaty and have this short to your skin. I'll just tell you that. And they're controlled wirelessly. Here's another example from the same special effects artist, also using a propeller. This is for a commercial for a well-known video camera company with snowboarders down in Argentina, also wearing a whole bunch of these LED strips. And here's a picture from Carol of something she just showed, programmed in BlocklyProp. This is the Parallax name, and she must have bought a 5-row by who knows how many columns. There it is. She's showing it to us now.
And where is your compact fluorescent shirt?
None of that here today. So I showed you the example on the activity bot. The new blocks. So there are really two things that are new. I'm showing you one of them. The first is that you can now initialize multiple strings of WS28 RGB LEDs. Okay, and so by that I mean many of these individual ones that are chained together with their serial out tied to serial in, or something like what's behind me. So you might see these two strips behind me, and they're controlled by the same flip multi-core microcontroller, but the LEDs are moving at different rates across the top of the toolbox. So these LEDs are tremendously popular right now for all kinds of special effects. I know one of the commitments I have coming up this spring is to animate a high school jazz band Disney theme with flying Tinkerbells that have these lights in them and with instruments that are also lit up. So if I'm doing that for them, you can expect to see more of these projects published from me.
This idea on this one, Ken, was if you take the LED strips and just put them on duct tape. That's what I used with black duct tape. You then can make them flexible.
Excellent. And so this strip that she's showing right now, you could buy these off of eBay or Amazon. They're dirt cheap with free shipping from China. Just look up WS28 You have to give them very specific voltage requirements, which can be the biggest hassle, but they're available in flexible formats and rigid formats. Just a lot of fun. Or you could simply buy these 10 packs from us. They're 15 bucks of these little individual babies. Oh, music is also new. So let's demonstrate that. Just gonna grab a USB cable. And then we will download this program because I'm using the same board that had the ping on it before. Whoa. So turn that off for a moment. I'm going to go into the code.
What speaker are you using?
I'm using the VHO speaker.
Okay, gotcha.
Okay, so there are a couple ways you can get sound out of the propeller. first I'll download this. Turn that off for a minute. As I mentioned, it's kind of crazy the way we like to do things around here. I'm surprised nothing is caught on fire. Okay, I downloaded. Okay, so the block is right here, and actually, oh, it's this one. I actually put the notes into an array, and then I indexed through the array at an increasing tempo, and I played do, re, mi, fa, sol, la, ti, do. So let's see if that works. And you can choose any octave you want. So it's in the pull-down menu. Okay, I chose kind of middle range octaves, I guess. Middle or higher, because those are the ones that I know. Now, something weird is happening in here. Okay, what I have is one demo talking to another demo. All right, so this is playing frequencies on, I think, what's called the A4, the 440 hertz scale. And behind me is my propeller-based tuner that's detecting them and then displaying them on playing the notes, okay? So through all the octaves. So that was actually listening to this. You can see it work a little more cleanly if I, whoops, restarting it. Anyway, the reason that demo didn't work perfectly is because I'm sampling each note for a little bit of a long time. I need to
I'm pretty sure I saw that in Close Encounters of the Third Kind.
You may have. Okay, so I've shown you some sensor blocks. And I just want you to know, for those of you who are new and just joined in here, there's a lot more than you're seeing than what I demonstrated today. These are some of the things that are supported: RFID, RF modules, color sensors, keypads, accelerometers, IMUs. It goes on and on. Remote controls, sound sensors, GPS modules. So yeah, it really gets crazy. And if there's something you want to block for, we'll try to support it, especially if it's hardware that we can actually provide to our customers. So no, there's a lot more there. Yeah.
Is it still true that you can go grab a block or save a block, a little piece of code that you want to write over, like for the WX board, and then import it into the S3 so that you could use the hacker port for a particular thing? I think Carol did that, where she used some sensor that was, had a block over on in another board, and then imported it so she could use it with S3.
Yeah, you can do that. People have done this, and it's kind of crazy. So what it's talking about is the ability to export blocks and then import them into another program. So in the case of the Scribbler 3, it may not have all the blocks you want. Okay, but there's no guarantee things are going to work when you start doing what he's describing. But as an example, what you can do is, like, here's a bunch of robot blocks, and I can download these blocks files, and it saves them, give it a name, downloads them. Then you can import them into another project that had a different board type. So yeah, advanced user trick, results may vary, but we can be a lot of fun.
It was the RGB
Yep.
WS28 block.
So what Carol has is a lot of really interesting, also time-lapse photography with the Scribbler, and LEDs that stay on for like 5 or 20-second exposures that are really neat artwork, actually. So what's coming up? By the way, I want to have any questions asked here pretty soon, because we're never sure if the Zoom tool is going to cut us off. But the webinars that are coming up on the 27th of March, this one's really good for teachers that want to get into robotics. If you missed our professional development courses, you can jump in here and we'll try to give you the same thing in 1 hour and really answer your questions. So we'll go over the hardware, the tutorials, assessment, the gotchas, the requirements, how to implement in class, logistics, whatever. And then this one's my favorite one, real world projects with BlocklyProp. I like to call it BlocklyProp isn't for baby programmers. That's at the end of April, and we will showcase 2 projects that are using Blockly extensively. One is an aerial pollination system on a quadcopter, where they were just suffering with all kinds of Arduino code that they did not understand. We introduced them to Blockly, got them started, and now they are highly empowered, and they're trying to win $1 million prize. And then the GPS autonomous surface vehicle I just demonstrated should be quite progressed by then. And then at the end of May, we have advanced projects with the ActivityBot 360. So teachers get a bunch of these, they say, what can we do next? Well, we will show you things like wireless control, color sensing, web-based control, competition ideas, whatever we come up with by then. So one thing I didn't cover are some of the things we're working on for you, and I see them popping up in the comments. One of them is about what's a microcontroller book. So Andy is engaged in completing the what's a multi-core microcontroller book, so that's coming. And we are also heading towards producing printed versions of the Blockly and C tutorials for the ActivityBot for future users. And we're working on, go ahead, Stephanie.
I'll get the GPS going in the Robotug, and then I'll send you the Robotug so you can use it out on Lake Tahoe.
This is great. Yeah, the GPS part, I'm not sure where to start with. If the Earth were flat, it would be easier, but anything you can share there, Carol, I'm going to use, as you know, so that'll be great.
Yeah.
People have also asked for an offline version of BlocklyProp. That is something that's coming, and we can do it right now. It's a little bit of a number of steps. You have to copy your code out of BlocklyProp and in a simple IDE, but there are a number of people who are perfectly willing to do that. So we will be posting the contents of that pretty soon. Yeah, and so someone asked, will this be available? The PowerPoint, yes. As soon as we're done, we'll PDF that, and then we will have a copy of the video, and Kate will figure out where to post those.
Yeah, I was going to pop in here and say that I'll be sending out an email to everybody that includes the PowerPoint, a link to the video, and then a short survey for everybody to give us feedback about the webinar and the experience. So any other questions you can ask also.
Yeah, and I want to reinforce what Kate said. This is really about what you need. We love this, so we love talking about it, but don't want to give you the illusion it's about us or our projects. It's really about what you can do with the tool. Tell us, too, what you need and what you like, and we will respond.
Mm-hmm.
I'm going to put a MEMSIC on each end of my house so I can monitor what I think is going on here. If you read about that yet?
I read last night that your home is moving and the walls are shaking.
Yeah.
Let us know when we have to show up and help you out, because I know how to move all that electronic stuff. Are there other questions that people would like to ask? Anything? John commented on the teaching materials and how important they are. I totally agree. This is the hardest part that others leave out that we're focusing on, which are providing good tutorials. So thanks for reinforcing that, John.
We have Nikos rewrite his mathematics treatise for the S2, that he did for the S2. Have him rewrite it for the S3.
Yeah, that would be good. He's on, so he would have heard that. Also, just want to shout out that we have to Nicole Litterer, we have a teacher who's been contributing the standards correlation and assessment material to Parallax for the last year. And the way you can get it is by going into learn.parallax.com. And if you're logged in, you can come under educators and then educator resources. And you can choose what you're using, and then you'll find assessment material. And this is tremendously useful because then you have a way to gauge the student progress and, you know, kind of an upper hand on them too. So Nicole's produced all that. It exists for the ActivityBot, the Scribbler, the ShieldBot, maybe even the BowBot, I'm not sure. So we're certainly trying to, you know, raise the standard here and provide the most complete educational solution. And it used to be that the teachers we were appealing to were kind of more the fringe, you know, the rogue educators who just truly love this. But now we're bringing in all of them and training them all and making things easier to use. But you know, in terms of complexity, that any complexity you see is equal to what you're going to be able to get your students to get out of it. So your investment gives capability to them. That's what I would remind you. So it can be a struggle, but once you start figuring these things out, you see big possibilities.
Hey, Ken, do you want to also mention that we were offering to educators to have a